Hi everyone, welcome back. Today we are going to see how Lambda can securely connect to a private Aurora database inside a VPC without exposing anything to the public internet. Now let's move into the architecture diagram. Here on the top left you can see we are using a region called US East 1. Inside that region we are creating a VPC called demo VPC. Inside the demo VPC, we can see we are using two availability zone, US East 1A and US East 1B. Inside each of the availability zone, we can see we have a subnet called private subnet A and private subnet B. Private subnets are accessible from the VPC but not from the internet. Now let's look into this green box. In this green box, we can see we have a Lambda function called app Lambda. This is a VPC-enabled Lambda, so it uses subnets in the VPC to create network interfaces for connectivity. When a Lambda function is attached to a VPC, AWS creates network interfaces called ENIs. In the selected subnets, these ENIs give Lambda a private IP and allow it to securely talk to resources like Aurora. We can also see that we have a security group called app Lambda SG. So what it does, it controls whom it can talk to. In our example, it would be Aurora. Now let's look into this blue box. Here we can see we have an Aurora cluster named app Aurora cluster. Aurora by default has a durable storage as data are copied into multiple AGs. In terms of compute, for this demo we will be using multi-AG cluster for high availability purpose. So in multi-AG cluster we will be given a writer instance and a reader instance along with corresponding endpoints for writer and reader. You can also see we will get this public access option while creating a cluster in Aurora. Setting it to no means that the Aurora cluster gets only a private IP address. Like in the Lambda, we will create a security group called app Aurora SG, which will control who can talk to it. For example, here only Lambda app Lambda SG should communicate with it. That covers our architecture diagram. Now let's move on to the hands-on demo. Now that we are in the AWS console, let's open VPC. In this VPC console, let's click Create VPC. In the VPC setting, let's give a name to the VPC. Scrolling down, we can see we have number of availability zone. We have value of 2 being selected, which is what we needed. For number of public subnets, since we don't need any public subnet for our demo, let's select it to 0. For the number of private subnets, value of 2 is okay. Scrolling down, we can see VPC endpoints. So let's select none as we don't need it for this demo. Now let's click Create VPC. Now let's wait till the VPC gets created. Now from the bottom right, we can see we have this View VPC. So let's click View VPC. In this View VPC, under this Resource Map tab, we can see we have a VPC created called Demo VPC that has 2 subnets in 2 availability zone. The first subnet is in US East 1A and the second subnet is in US East 1B. So now that we have successfully created the VPC, now let's create security group for both Lambda and Aurora. So let's open it in 2 tabs, one for Lambda and one for Aurora. In this security group tab, let's click Create Security Group. Let's give it a name. For description, let's put dot. For VPC, let's select Demo VPC. For now, let's click Create Security Group. Moving on to the next tab. Now let's click Create Security Group and let's give a name for the security group. For the description, let's put a dot. For VPC, let's select Demo VPC. For inbound rules, let's put PostgreSQL. Source should be custom, and for value, let's select app Lambda SG. Now let's click Create Security Group. Now the security group for Aurora called App Aurora SG is created successfully with properly configured inbound rule. Now let's look into this App Lambda SG and go into this outbound rules. In outbound rules, let's click edit outbound rules. In the outbound rule, let's delete the default rule and click add rule. Now let's select PostgreSQL, and for custom, let's select the value of app Aurora SG and click save. Now we can see both security group needed for our Lambda and Aurora is created successfully. Now let's move to the Aurora. Let's click Aurora and RDS. In Aurora and RDS on the left hand side, we can see we have this subnet groups. Let's click this subnet groups. You might be wondering what this subnet group does. Before Aurora can be created, we need to tell AWS which subnet it's allowed to use. That's exactly what a DB subnet group does. So let's click create DB subnet group, give it a name. For description, let's put dot. Now let's select a VPC called demo VPC. In the availability zone, let's select 1A and 1B. For subnet, let's select both of the private subnet. Now let's click create. We can see that the subnet group called app Aurora subnet group has been successfully created. Now from the left hand side, let's click databases. In this databases tab, let's click create database. So choose a database creation model. We will be using full configuration. For the engine options, we will use Aurora Postgres compatible. Now moving down, we can see we have this field where we will add the name for our cluster. Now let's move down. For master username, let's keep the default of Postgres. For credential management, let's put self-managed and let's enter the password. Now scrolling down, let's make it serverless v2 for the instance configuration, and let's change issue from, let's say, 0.5 to 1 for the demo purpose. For the availability and durability, we will be using a multi-AG deployment. So select this create an Aurora replica or reader node option. Scrolling down, now we can see we need to select a VPC. So let's select our newly created VPC called demo VPC. Moving to the DB subnet, you can see that recently created subnet group has been auto-selected here for the DB subnet group option. For public access, we will be selecting no, as this database will be strictly private. For the existing VPC security group, we will be selecting App Aurora SG security group that we previously created. Scrolling down, we can see we have many options, but we won't be making any change to it. So now let's create database by clicking this create database button. It might take some time for the database to be created. So right now we can see an error saying that database cluster didn't work because of the reason DB instance already exists. So let's just change the name quickly by adding 1 to it. Now let's click create database. Okay, again we see that we have didn't work because that already exists. So let me select different name, cluster 2, and click create database. Now you can see that we have successfully created a database in Aurora called app Aurora cluster 2. So let's click it. We can see that we have created a writer instance and a reader instance, and we can also see the endpoint name for writer and reader. Now that we have successfully created an Aurora database, now let's move on to the Lambda part. So let's open Lambda. In this Lambda console, let's click create function. Let's give a name to our Lambda function. For runtime, leave it as Node.js. Now for the additional configurations, let's select this VPC. Under VPC, let's select our demo VPC. Under subnet, let's select both of the private subnet. Under security, let's select app Lambda SG. Now let's click Create Function. Let's wait till the function gets created. Now we can see that we have successfully created the function called app lambda. Scrolling down under this code tab, let's click upload from and .zip file. Here let's click upload button. Here we can see that we have a file called lambda aurora demo.zip. So let's upload this zip file and click save and wait for the zip file to be uploaded. Now we can see that we have this index.js file. So let's click this index.js file. In this index.js file, let's copy and paste the values for host, user, password, and database. Now let's move to the Aurora part. In this Aurora section, we can see we have this two endpoint, one for the writer and one for the reader. Please keep note that the writer instance has been deployed in US East 1, whereas the reader instance has been created in US East 1B as shown in the diagram. So let's move to this App Aurora cluster 2 and copy the writer endpoint for this demo. Let's copy this and paste in host value. For the user, we set to Postgres. We set it to Postgres. For password, let's set it as admin123. For database, it would be Postgres by default. Now we can see that we have entered all the necessary values in order to connect to our Aurora database privately. Now let's go to the test tab. Under test tab, let's click this button called test. Now we can see that we have successfully executed our function. Let's look into the details. In the details, we can see we got a response back where our body has DB name as Postgres and user as Postgres. Now let's look into this code tab. In this index.js, we can see that we have created a client with all the necessary connection details. In the try block, we can see that we are executing a query and we are stringifying the rows inside of res and returning back a response. We can see that this query has been successfully executed in Aurora database. Now that we have verified the Lambda can successfully connect to Aurora, let's quickly summarize what we have built. To summarize, we connected a VPC-enabled Lambda function deployed across multiple edges to a private multi-AG Aurora Postgres cluster using proper subnet and security group design. This gives us a production-grade, highly available architecture. Thanks for watching. If this helped you, please like, subscribe, and I will see you in the next video.